save this model, save as. We will save it as, let's just
شيل
call it
الورقة
guys,
شيل الورقة توقيت التصوير شيل الورقة الوردين
Feedforward dash feedbackward.
اوكي
There should be dash, guys. It should be a continuous thing, okay? Feedforward, feedback, forward. So that's it. We did this. At the beginning, we said we have to change the model configuration parameter. We will change this variable step to what, guys?
Fix.
Fix step. And this one actually change it to Euler, and this one let's make it 0.0001. It's okay. It's okay. Or let's make it just 1 millisecond, like this.
0.001?
0.001. 1 millisecond. Now data import export, we will change this one to limit data, we will make it 1000. Okay guys? We will uncheck this one. Then we'll make OK. After that we'll start. Now at the beginning we would like to put the system. System is a transfer function under the continuous library. We can take the transfer function, this transfer function, make it bigger a little bit. We'll call it GP. This is GP of S, right? So which is the process, okay? The transfer function for the process. I will just give you something, okay? Which is, let's say, the transfer function for this process will start with the steady state value. Let's say it's going to be 5, and the numerator will take some time. Let's say it's going to take 40 seconds until the system is going to be stable. Is that good? Yes. And we will have as well for this system transpose delay. Transpose delay under the continuous again, you can get transpose delay and transport delay. We connect it to this one. You have to connect both of them, okay, guys? One of the actually problems that you will make, they will not connect them and you will just put them beside each other, which is wrong. It's a signal and you have to connect it. And this transport delay, guys, it's actually the exponential form. How much the time here? We'll make it, let's say, 10 seconds, okay? 10 seconds. After that, it will take 40 seconds for this one. So 40 times 40, it's about 100 seconds, 160 seconds plus the 10 seconds, so 170 seconds until it reach what, guys? State value. Is it clear? And 40 is the tau. 40 times 4, it's what, guys? 160 seconds. Plus the 10 second delay, 170 seconds. Anyway, it's okay, we can change the time here and we'll make it, let's say, 500. Okay? Simulation time, yes. Then save our work. Then we can get this one a little bit close to this, so we can just consider them, both of them, they are GP of S. Both of them, not just only this one. Okay, guys? So this is the system. Let's make right now another one. I will select both of them, right click, drop and drag. Drag and drop. Now it's working, okay? Okay, now I would like actually to change this one to what, guys? GD of S. And let's make GD of S, it will take less time actually, not 40 seconds. Let's say it's gonna take about 15 seconds. The transport delay, but no, the delay should be what, guys? More than that one, right? This
Should be more.
do you remember? It should be more, right? And for the system, it should be faster than the delay of that one. So we'll make it 15, and this one is just 1. And transport delay, this is going to give you just, guys, the response, how it will be look like. And this one, we will have it, what, guys, it should be more. Let's take it 20 seconds, okay? Just for example. If you would like, you can write this one down. Like just exponential minus 20 s. You can write it just, okay, guys? And we can take copy and paste it over here as well. This is what, guys, 10s, right? Is it okay, guys? This is going to be a label.
إذا كبرت
Which one? This one? No, this is just for the graph. That one for the KP. Again, yes, it will actually appear or not. That does not appear according to the site. Yeah. Just to show you that it's 20 seconds. I put it 20 seconds, so you will not forget. This is what guys 10 seconds. Okay? You can write down just here delay 20 seconds. Right. This is gonna be much better.
Minus D minus L.
What is it?
So it's the same of D minus L. That's
Oh yeah,
that's the-
yeah. That's why I gave to you this one. So guys, then I will take actually from here. We will build it in an easy way, guys. We'll take the sum, but the sum, guys, to make this one, the other signal, the second signal, to make it in the upper, in the actually here in the, let's say, upper part of the summation. So I have to double click this one and make what here, guys, plus plus, then the column. You remember this?
Yes.
The column means do nothing actually, or don't
So
add
you
a
don't
signal.
have to put the code.
What?
You don't have to put the code.
We
it will
have,
be مش زود 90
I know that, but it will look weird. Look at this.
ما ممكن زود 90
If I didn't put it, and I have to do it this way, then I have to do it that way. So,
حاليا الكون موجودة في البداية صح؟
what is it?
حاليا الحين بهالطريقة أول شيء
The column is there, but I have to make first of thing the plus two pluses, then the column.
لا هو
The
يقصد
column means it will block the input. If I put it to three pluses, it will want plus plus plus.
Okay.
But if I put column instead of one of these pluses, let's say plus column plus, then it will take plus
Yeah, I know.
counterclockwise.
لو بس two pluses.
Then I would like to make two pluses and then the column. Why? Because I would like actually to do it in a very nice way. Okay?
لا هزاع ما بيكون زود 90 بيكون شيء زود 45 شيء شيء
No, if I did, yeah, you mean just two pluses? It will actually make it like the column in the middle. Okay, just for the representation, I'm giving it to you in this way, guys. Why? Because just to mention that this is the system and this is an intruder to the system. Okay, the disturbance. So mainly this is my line, the main line, and this is just a disturbance that came actually from outside.
Some from continuous?
Anyway, this is just the presentation. What?
This is not continuous?
This is from the continuous system.
No, no.
Yeah, from continuous. No, from commonly used block. Commonly used block summation.
بس كيف ينطلع عشان تنسى تسوي سيلكت عندك صح؟ عشان تنسى.
You can select right click, hold it, then drop it, or just copy paste it. Copy, then outside paste.
This is GFF
Okay, guys? So now I have the system. Here, guys, it's going to be the disturbance, which is I will go to the source and I will make two steps. One of them I will call it what, guys?
disturbance
D, disturbance, and the other one I will call it right now V, which is what, guys? Voltage. Okay? So the voltage, let's make the voltage is 0. It starts from 0 and it's 1, final value. The same thing for this one, it's 0 and 1, okay? But it's not gonna start at 0, it will start at what, guys? At 200. But the final value, I will make it at the beginning 0 because I don't want to put the effect of what, guys, of the disturbance.
براسنا الأولى.
Exactly. Okay? So then I would like to add both of them and let's right now draw the response, okay? So if we see it, guys, we will take this one up to here. This is scope. Do you want from me to make right now workspace? You will do it, but I'm not gonna do it. Okay, guys? No. So this one, we did it so many times. So right now, limit data, guys. I will make apply, no, more than 5,000. Then, guys, start the simulation. صور سناب مين يصور فيديو عادي لا مش مين يصور فيديو
هو الأستاذ.
لا والله جي قلت لك بدو معه
بدر يا أخي
ترى نصور ولا-
عادي صور
فاضل وايد
سؤال الفي ستارت له ستيب تايم زيرو ولا
Yes, tell me.
الفي ستيب تايم زيرو والفي ستيب تايم ديفرنت
Yes, this is V. It will start actually from 0 time. It will change the value from 0 to 1. So at time equals 0,
فاينل زيرو
it
فاينل
will change actually from the initial value 0 to 1. This is the unit step, U of t. But for the D, at 200 you will have the effect. But I put actually the initial value and the final value 0, 0 because I don't want to change it right now. I will do it one later. Okay. Now, guys, please, yeah, for the system, for this system, if I run the system, what will happen? What do you think? Exactly. So if I put the scope, guys, maximize this one, you will find that there is a delay, which is the 10 second, right? And then I will have the response. Look at this response. It's gonna take about until it reach 100, yeah, 170. This is what we calculated, right? 170 until it reach what, guys? The state value somewhere here, 98% of the file. State value file. Is it clear?
Yes.
So this is for the system, which is a normal system, and there is no disturbance. But what about, guys, if I add the disturbance? At what time? At time 1. Sorry, at time 200.
ايوه
But the initial value, the value is going to change from 0 to 1. Okay? So it's a step, again, step input, but at time equal to 100. Then I will run it for 500. I think it's going to be enough. What will happen, guys? The system, look at this. So the disturbance effect will reach to 1, but there is no feedback controller to return it back. And it's just a disturbance that was affecting, adding something to the output. That's why we will have the effect forever. And the steady state value, it will reach what, guys? 5 plus 1, 1 from the steady state disturbance, from the major disturbance, and 5 from the system, then it will reach 6. Okay, guys? Because we have addition here. Here, the steady state for this one is 1, and for this one is 5. Then 5 plus 1 is going to be 6. And this is what it shows you here. Is it clear, guys? Now, what about, guys, adding a feedback controller to the system? We will add at the beginning feedback. Is it okay? Is it okay, guys? But before I add feedback controller, do we need really to put an input to the V, or we can just make the input 0? There is no voltage. If we put actually the input here 0, then you run the system, what will happen, guys?
After 200 seconds it will
After 200 seconds, you will have just the effect of the major disturbance. And after 200, you just see the effect of the disturbance, right? Is it clear, guys? Yes. And it's to 1. Because it's like that, the system will give you 0 here, but the disturbance will give you 1 with this actually regime or response. That follows this actually transfer function. 1 over 15 s plus 1. Is it clear, guys?
Yes.
Now, let us start with what, guys? With the feedback controller. I will remove the step input. And what I will do actually, I will take this one and I will put it over here. Then we will remove this one and I will change this one to what, guys? The desired output. What's the desired output? It's the temperature because I'm controlling temperature here. So I will put it TD, which is desired output. I'm not sure. I said that so many times, guys. And even in the exam, you are doing a mistake and you are just putting there, this is in the control, especially in the closed loop controller, you are telling me that this is an input. It's not an input, it's the desired output. It's a set point, it's a reference, but it's not the input to the system. Input, that means it's a voltage, like the voltage here. This is an input to the system. But this is desired output, because this is the scope here, it's temperature, and you have to have a desired temperature here. It's a closed loop control system. We said that so many times, I'm not sure why we did it like that in the exam. Anyway. So right now, guys, let us start with the PID controller, okay? Now, how we can actually do the PID controller? I will take a gain, and this gain, we will make how many gains out of it? Just right click, drop. Let us do this, guys. Let us change this one to KP. Then copy paste, copy paste. This is gonna be ki, and then I have what guys here? kd. Now guys, we will take under the continuous, we'll take the integrator and what guys? The derivative. We know that the integrator for this and the derivative for that. If you would like to remove the integrator, you cannot just delete it like this, guys. We'll go back again. I mean just the wording here. So you can just right click and go to the format and uncheck the show block name. Okay guys? If you think that will look much nicer this way. Yeah. Now guys, just to make it actually fitting over here, we will, what I'm going to do, I will zoom out, put this one. Oops. Yeah. Take this one like this. Take this 3 aligned with this. Take TD just back a little bit, and that's it. Yeah, good. Now, I will take this one, guys, and because I know that this is going to be the output, but I have to put here what, guys? 3 pluses. I need all of them, so I'll take this one, and this one from here, and then I will take also another summation, but I will change it to what, guys? To column plus negative. Why, guys? Because this is the feedback term, right? The error can be calculated from desired minus the actual. So this is the error. After I connect it to the ki, which is then I can connect it to the other two because this is the error. Right, guys? Then I will take the feedback. I'll take it up to here. Then I will continue this one from here to here. Clear, guys?
This is clear.
This is the feedback controller. Do you want to make this one as create subsystem? Let's make this.
Yes, make it.
No need?
Make it. أنا نشوف كيف يسوي.
Okay, so you can actually select this one from here, from the beginning up to the end. Then right click on one of these blocks, not on the space, on one of these blocks. And then you will make create subsystem from selection. Just select them, right click in one of them, and make create subsystem for the selection. Then you can just resize this one. Double click, go to the input one, it's the error here. And the output is what, guys? The B, right? For the system. And this is what, guys, we call it PID controller. So it's okay, guys.
ليش ما حطيت سنسر؟
What?
سنسر.
Sensor? Yeah, it's a good question, by the way. Because I have an ideal sensor, which is this signal. I have the measurement T, right? In the actual life, we don't have this measurement. So we have to implement a sensor. If this sensor will give you exact measurement, like the line here, then the H, which is the transfer function for the sensor, is going to be how much? 1. And the output is equal to the input. The output of the sensor, it's the same as the actual value of the system. So I'm considering here the sensor is equal to what transfer function is. It's very ideal sensor, perfect sensor that give me the exact measurement that I need from the system.
So can we make it open loop?
Can we make it open loop? What do you mean by that?
Because no need to measure the error. Because we have PID controller, so output equal input.
No. Look, to reject disturbances, external disturbances, environmental disturbances, any other disturbances, you have to have feedback controller. And also, one of the objectives of having a PID controller, for example, if you look at the steady state value, it was 5, right?
Yeah.
I would like to make it what?
1.
1. It's exactly similar, not necessarily 1 actually, it depends on the desired value of what? Of the temperature. So I wanted actually to follow a certain value. So in the open loop control system, it can succeed actually, it can succeed for the first time to do it, yes? But if you add any disturbances later on while the system in operation, it cannot actually handle it because it's blind, it cannot read. There's no sensor, no feedback actually from the controller or from the control system to correct this value or the change that happened to the output. Is it clear?
Okay.
Now, Look guys, what I'm going to do, I will go to the disturbance and I will remove the effect of the disturbance at the beginning, just to make sure that the system is working, okay? Then I will go to the TD and we will change the value from 0 to 1, from 0 step time. But the final value, let's make it how much guys? 1, for example. Temperature is 1. Maybe we'll put it 50. It depends actually on your desired, on your set point. So we'll save this work and we will run the system. Still, I didn't actually change the PID controller. I didn't make the PID. How we can make the PID controller? Using what, guys? One of the options, using Ziegler-Nicholas method, we can tune the KP, KI, and KD, right? But let's try it right now for the current one. As you can see, it's gonna go out. It's gonna be crazy. Then what should I do, guys? You are not concentrating.
KI والKD بلس 0 اسمه بلس 0
بس لا
KI والKD بلس 0
KI and KD. Let's put them at the beginning 0. What do you think, guys? 0 and 0. This is trial and error. We cannot do trial and error, guys, right? So we have actually to try it. Yeah. Actually, the system is. Look at this, guys. It has a oscillatory motion until it's getting to the steady state value. But as you can see, guys, steady state value is not equal to the 1. How can I actually remove this? By increasing KI or just introducing KI, because it will eliminate the error. So let's make it 0.1, for example. I will have more oscillation, by the way. By the way, it's right now getting crazy. It will go out. Let me reduce the KP.
We can find the exact
using Ziegler-Nicholas. It's better.
بس هذه مش هاي
You have Ziegler-Nicholas method, which is you can find all of your parameters, right? But let me just do it by trial and error right now. No, you have to design them using Ziegler-Nicholas method. You have tau, you have L, you can go and from the PID, from the table, you can get the PID controller parameter. Look at this, guys. We put actually 0.01, the KI. It's looking nice, right? We can actually increase KI a little bit, make it 0.02. And increase KD, let's make it 0.1. Then start the system. This is just for example, okay, guys? But again, if you would like to do it in a proper way, do it using Ziegler-Nicholas method. This is really great, okay, guys? This response is really okay. Within 100 seconds, guys, you will have the steady state value, which is exactly 1 as it's requested from the controller. Okay, guys? Guys, if I would like to reduce the overshoot, what should I do?
Increase KP
KI.
KI
right? KP خليها هذه. يلا. Look at this, guys. Reduced. Okay? Anyway, that's okay. Come on, guys. Now, if we reduce the KI برضه, it will reduce the overshoot. Let's make it 1.5, for example. Okay, now reduce the overshoot, right? You can reduce it more and more, but I think it's okay. ممتاز. Now, can I add the D? I have the feedback controller. Can I add D, guys? What do you think? What will happen? What do you think? What will happen if I add D and the value is 1 here? But it will go to another steady state value. It will go back to the 1 again. What do you think, guys?
It will go up and
Another steady state value?
لا هذا PID controller.
Yes. Then what? It will take it back again, but it will take some time, right?
it will go and come back.
It will come back again to the same steady state value, which is 1. And this is the objective of the PID controller. But look at the guys, the effect. How much time it will take actually for the response to go back again to the same steady state value. Let's take it here from 220 until let's say 300, more than 330. So it's more than 100 seconds. 100 seconds and the system was not reaching the steady state value. Look, if it's a heat exchanger or something like that, how much time we lost? Maybe something wrong will happen during the system because it was not maintaining the temperature that, let's say, a chemical process or something happening was in the heat exchanger, or no, it's a heat exchanger actually, it's a cube actually. We are taking Q or putting Q to the system, to the other side. So there was something wrong, right? And the efficiency of the heat exchanger will be low. Why? Because it was not maintaining the same. That's why. What's the solution, guys? To add what, guys, here? Feed forward. Let's make the D here, and I will make what, guys, here? Another transfer function with transport delay, and I will call both of them what, guys, here? GFF. Okay? Now, can you tell me how much GFF minus, guys, let me show it to you here. Guys, how we can find the GFF? Just wait. Take some time. Yeah. Now, GFF شو تساوي يا شباب؟ minus GD over GP.
ما يبين.
هلا قرن عزوز قرن عزوز.
Zeus, give me your pencil. Give me your pen. GFF equal minus GD over GP, right? Now, what's the GD? So minus the first one. The GD is telling you that you have exponential 1 times exponential minus 20s, right? Over what, guys? 15s plus 1 times this one. I will just flip it, right? GP. So it will be the reciprocal of the GP. So it's 40s plus 1 over what, guys? Exponential over 5 exponential what? 5 exponential minus 10s. Is it right? So this one will be minus, guys, let me just continue this. This is a simple operation, okay, guys? So minus exponential with exponential, what's gonna be, guys? Exponential minus 10s. Why? Minus 20s plus 10s will be minus 10s. Is it clear? Yeah. What about this one? This term, guys, this is 40s plus 1 in the upper part, numerator. And this is 5 times 15, how much, guys? Is it 45? How much? 70?
45.
45.
75, right? Guys, how it would be 45? Yeah, multiply 5 by 10. 50. And plus half of it, which is 25, it's going to be 75. S plus what, guys? 5, right? So that's it. This is actually the transfer function that we have to add to our system. Let me do it, guys. Okay? Here, we would like to make what, guys, here? This one in the numerator, we will put the negative sign. Should we put the negative sign for both of them? Minus 40, space, minus 1. Is it okay, guys?
Plus.
Minus 40, you know, guys, it will, the negative can go inside, right? Guys, this is basics, right? Negative will go inside. Come on. So, okay. Now, what about this one, guys? It's 75 and 5. The transport delay, how much, guys? It's 10. Minus 10, right? Which is, this is going to be what, guys? Minus 10. But we cannot actually repeat the same name. That's why we keep the 1 here. Or let's say keep star or something like that. Okay? It's just a name. Anyway, this controller, it's called what, guys? GFF. I will take an input from the disturbance it will do something, and it will give me a proper input to the system. This proper input to the system should be actually added by a summation. I will take this one back, and we'll take this two together, the summation here, and then we will take it to the system again. Now, what do you think will happen, guys, if I add the system at 200? What will happen, guys?
Consider.
Let's try it.
You will get rid of the step.
Look at this, guys. It's a clear one exactly. And if we go to the 200, 200.
لو حط قيمة كي بي وكي
Here.
أكبر عن الواحد.
It's nothing, right? But I have a perfect model. That's why I will get rid of it. If I have some mistakes, delay in measurement, what will happen, guys, to this one? Maybe it will be a delay by 1 second more, 1 second more. Then what will happen to the system? You will find there is small glitches over there. Look at this, but it will return back. Okay, guys? But this is also, we'll go back to your question, Walid. If we have a very good sensor, it will get rid of the effect of the measure disturbance. But if you have a very bad sensor, and it will take, let's say, 1 second, look at this, you will suffer again from, let's say, around 80 second or 60 second delay of not maintaining the same temperature. Okay? So that's why this one, it could be 10.1. If it's 10.1, maybe I will have just a small glitch, which is 0.1 will be for the sensor. Look at this. Okay, guys? Okay. What? This is transport delay. The transport delay, we found it, it's minus 10, right? Yeah, it should be minus 10s. If you have a very accurate sensor, that give you that exact actually value with no time. Okay, so with no delay, then you will have what exactly the system actually will get rid of the measured disturbance, as you can see. Is it clear now? So can we see this as well? If we put, guys, the TD 0, or there is no input from the feedback. Let's do it. We didn't do this, right? Then forget that there is a feedback. Then what will happen to the system? What do you think? Look at this. What's this actually, guys? This is after the 200. It's what, guys? Do you have some oscillation here, right? Or let's say noise. This is because of the disturbance, by the way. But can you read actually this one, guys? 10 to the power minus 14. It's what, guys? It's 0. Okay? And that means it's 0 up to the end. Because this is actually the value, it's 10 to the power minus 14. It's very, very small. It's almost 0. It's like that you are maximizing. What, guys? This and this should be what, guys? If we take this one, let's take it. Oh no, I don't want it to zoom out. Yeah, I can actually change the axis here. The minimum minus 1. With maximum is what, guys? Is 1. Look at this, guys. It will be what? 0. Is it clear? That one was 10 to the power minus 14, that's why it was showing the noise. Now, guys, if I take this one again back, then I will have the system which is to control the feedback and the feed-forward system together. Yeah, that's it. Just find them and put them. That's it. It's easy.
Perfect system.
It's not gonna be optimal control using Ziegler-Nicholas method, but you can get another actually performance. By the way, Ziegler-Nicholas not necessarily to be the perfect one that you have to have for your application, but it will give you an optimal. Optimal, what's the meaning of optimal? The response is okay, and the power consumption is okay together. You can have a balance. But if you prepare to get rid of, to make, let's say, a perfect response at the expense of the power, then you will start to tune. But as a startup, it's good actually to have the Ziegler Nicholas values. Then you can do just retune it again to in the system to get the specification or the, let's say, the parameters that you want for the system. What are the parameters? What are the parameters? Like steady state value, setting time, rise time, and all of these parameters. Okay, guys? Any questions, guys? Any questions? Sure that you will be ready for the this? It could be feed forward, it could be feedback work, it could be it's evaluation. Let's say lab evaluation. We'll have 10 marks out of the total marks.
يلا بسم الله نشتغل.
Good teamwork.
نشتغل.
Yes, now you can actually start. You have 10 minutes. Next week, yes. By the way, guys, this lab should be submitted next week, Monday. You know that it's 1 week before the lab. Why I'm doing this for you guys? To be ready for the evaluation. لا 2 person.
طب متى اللاب هذا؟
الاثنين شو بيسمي فيه يا سيف؟
متى؟
الاثنين يا سيف بتسلموا معنا ريبورت. سيف ركز معنا يا سيف نايم.